The limit comparison test is really useful when you can't use the direct comparison test and integrating would be a pain. So suppose we have two series with positive terms for all n greater than or equal to n. Again, that means that from some point on, all the terms are positive. We can always take off the first 100 terms or 1,000 terms because the sum of 100 things or 1,000 things is finite. So then we look at the limits of the sequences inside. If that limit is some constant that's not 0, then both series converge or they both diverge. Again, this limit being finite means essentially the series are behaving the same way. They're approaching infinity at the same rate. So if one of them converges, the other one's going to. And likewise, if one diverges, the other one will. Suppose we take the limit of a sub n over b sub n and we get 0. And the sum of b sub n, the one in the denominator, converges. Well, if this limit is 0, it means overall the terms in b sub n are bigger. So if b sub n is converging, then a sub n is probably smaller and it will converge too. If, on the other hand, the limit as n approaches infinity of a sub n over b sub n is infinity, and the sum of b sub n diverges, then the sum of a sub n diverges as well. Again, what's happening here? A sub n is probably larger than b sub n. So if b sub n is a divergent series, so is a sub n.